really glad that you're all here. My name is Brent, and I'm the organizer of the Silicon Valley chapter for the Self-Driving Cars 101 community, and I will be moderating our panel of experts today. So before I have them take a few minutes and introduce themselves, I just want to say a couple things. One, I want to thank Parallel Domain for hosting the event this month. I'm very grateful for that. I want to let everybody know that the event is being recorded. And so I will send out that link as soon as possible. And we'll post it on the Meetup page as well, so people can review that. If you have questions as we go along, please just enter them into the Q&A tab, and we'll either address them as we go, or I'm going to try and fold up the panel at about 4:45 and give us 15 minutes on the back end to answer people's questions. So feel free to put those in there, and we'll be monitoring those as we go. I will try to close this out as close to 5 p.m. as possible, I promise, but we might run a few minutes over, so forgive me. And every time I do one of these, I get a whole slew of LinkedIn invites and connection requests. And I would love to connect with everybody in the Self-Driving Cars 101 community. I would just ask that when you send me a connection request, just mention in the notes that you're part of the Self-Driving Cars 101, and that will separate you from all the sales pitches that I get every single day. So that's what I would ask for all of them, everybody doing so. So great, let's go ahead and kick things off. Everybody has a different order on their screen of panelists. So I'm going to start and just ask Sheila, if she would, to give us a couple minutes about her background and HERE technologies. And then we'll go to Christian, and then we'll go to Kevin, and then we're going to roll into the overall questions. So Sheila, why don't you take it away and give us a couple minutes on you and HERE.
Sure. I'm Sheila Nedelku. I'm Director of Product Management at HERE for our Automated Driving division. I've been with the company for about a year. HERE is a data location platform company. And before HERE, I was at about 5 years now.
Wonderful. All right, Christian.
Awesome. Hey, everyone. Excited to join today from beautiful Berlin, as part of our company is here, and I decided to hop on a plane during the pandemic, which was actually a good experience. Yeah, Zappix is all about data connectivity, data orchestration in that sense. We started our journey back in 2016, focusing initially on the connected vehicle space, allowing developers and companies like Daimler, like Volvo Trucks and others to essentially take the data off the vehicles and distribute it to the different application teams, also to different partner teams, and have been working on autonomous vehicle use cases, essentially around API, event stream orchestration, mainly for off-board data in that sense. So everything from data as a service to different activities that also then allow the vehicles to operate much more autonomously within a larger ecosystem. Excited to be at least virtually back to SF again today, join the panel, and curious for the discussion. And if you want to find more about Zappix, please feel free to ping me, Christian Umbach, through LinkedIn, or you can always visit zappix.io as well.
Great, thank you. Kevin, give us a couple minutes on you and Parallel Domain.
So hi, my name's Kevin, founder of Parallel Domain. Our company, we are a data generation platform for autonomy, and our focus is really on generating synthetic sensor data. Things like camera and LiDAR data, so that systems like autonomous vehicles, delivery drones, robotics can see the world and understand that world around them. We'll talk a lot more about the company and what we do probably throughout the course of the panel, but my background comes from computer graphics. So I come from kind of animated movies, worked on movies like Brave and Monsters University at Pixar, spent some time at Microsoft working on the Xbox, and then before Parallel Domain, I was at Apple Special Projects Group, where I was working on their autonomous systems project using simulation and synthetic data to try to accelerate some of their efforts. So really coming at the autonomy world from a graphics and data perspective, which is why, you know, some of this panel is so relevant. You know, like Christian, you can find me on LinkedIn, Kevin McNamara. You can find us, Parallel Domain, at paralleldomain.com. And my personal email is just kevin@paralleldomain.com. So feel free to reach out. Happy to chat with anybody who's interested in data, autonomy, machine learning, computer vision.
Cool, awesome. All right, so let's roll right into the questions. Let's start by just talking about the role that data plays in the development of autonomous vehicles or autonomous mobility overall. And some of the more innovative approaches that are being taken today that can be used to accelerate that development. And obviously, each of you are coming from different data providers. So feel free to chime in on that. Who wants to start?
I'd be happy to jump in. This is probably the question that might be most relevant for us at Parallel Domain, because we're all about enabling kind of an alternate way of getting data relative to the status quo. So what we see with a lot of our customers, and again, we're really primarily focused on vision and sensing and perception, but with our customers, the problem is usually all about data collection and labeling, right? How do I get examples of the data I need at a high enough volume? And then how do I label those very, very accurately? And you know, for any of the folks on the call familiar with machine learning, this may mean collecting millions and billions of images and then using humans to hand annotate those. And there's a whole host of issues that go with doing that, from quality problems to that being very slow and time consuming. And so we find, you know, one of the more kind of innovative or revolutionary ways to get data for training machine learning systems is to generate synthetic data. Especially today with the advancements in computer graphics, we can generate synthetic camera data, synthetic LiDAR data that is to a machine realistic enough to teach it how to see the world more accurately. And so a lot of our customers are actually using platforms like ours and many others to generate synthetically generated data that has perfect labels, because you've got a machine that knew what every pixel was when it generated that image. And then they can use this to train and validate their computer vision systems without having to go out into the real world to get data. So this allows them to move much faster. There's not the safety risk of putting vehicles on the road. It's typically much more cost effective. And so this is one of the most interesting, most fascinating areas of machine learning in my mind. How can we actually break that cycle of having to use real world data to train these models? So that's something that we're very focused on.
Now, Sheila, here is super deep in real world data, right? I mean, you're developing the HD maps and everything else. Are you playing in that world of synthetic data at all, or is it just full on? How are you handling that?
And I think data plays different roles in AV development, right? So when we're trying to test vehicles and get them road ready, I think, there's simulation, synthetic data, all of those things. When we actually put the vehicles on the road, our customers are asking for a real world representation of reality. And right, how do we do that? So what we do right now is we look at many different data sources to be able to create our maps. And our maps are one of the most, integral sensors in the car that helps it drive autonomously, right? And it varies with how OEMs are actually integrating or designing their systems, how dependent they are on the map, or if it's, just kind of one of the more equally based sensors it depends on. But we have a fleet of vehicles that goes and gathers ground truth itself. But we also have a strategy that we conflate multiple data sources. So we are using satellite and aerial, we're using probe data, we're using our own vehicle fleets, we use OEM sensor data to complete our maps. So that, one of the biggest requirements for our customers is it has to be super fresh. If an object that the car uses for localization is no longer there, it needs to be updated in the map within minutes if possible. And the real strategy behind that is you can't just keep driving the roads. So you have to use cars that are already out on the road to be able to feed that data. And what I would say is not all data is the same. I need data of a very specific quantity and quality that actually contributes to my maps. And it is not in abundance right now. So we are waiting for these kind of ADAS equipped vehicles to really get out on the roads in more quantity to be able to give us full continental coverage.
Wow. And, and Christian, what about, so Zappix plays both on vehicle and off vehicle, right? So
actually mainly off vehicle in that sense. So for us, the core area that we're looking at or that our customers are tackling with the product is basically the broader data orchestration with kind of the ecosystem around the vehicle. So that can be around the map, for instance. So Sheila already alluded to some of the OEMs, some of the approaches see kind of the map as the center, and others are seeing, let's say, the map input as one key input, also in terms of maybe out of vehicle data streams, but may see other sensors, from parking lots or any type of other vehicle systems as well, potentially as input as well, where I would say the caveat is usually a focus on use cases which are not as performance critical in terms of requiring below 100 millisecond reactivity, because they're usually involving cloud communication or cloud to cloud communication, and are only then feeding down to the vehicle.
And so let's talk about that a little bit, right? The data that is feeding down to the vehicle, the data that's coming off of, here's maps, and I know that parallel domain plays in this as well. There's a lot of concern around data privacy today about people showing up on maps or on video being captured by vehicles driving around, license plates, brands, all this kind of stuff that everybody's very sensitive about. How are you all tackling that? How is that being addressed, and how much of an impediment is that in AV development today for the data that these companies need?
Yeah, maybe I'll take a stab at that first. I think in terms of, from a, let's say, pure technologist perspective, it's a huge impediment, because it basically turns one big problem space into many problem spaces, which are essentially defined on a country, sometimes on a state level. So there's this law of lands, essentially, where companies are put in, our teams are put in a situation where basically the way they handle data privacy differs from country to country. At the same time, I would say one way of going about it, or maybe I should highlight it, this was the technologist perspective. At the same time, obviously, I think there's a huge value of setting a high bar for data privacy, and some regions have been pushing that a little bit harder. And in some ways, let's say GDPR has inspired other regulation and become the gold standard for at least a lot of development teams to be a little bit more strict on regional data privacy, but through that meeting more and more laws in that sense. And it basically ensures in the question of what's happening with data and how private is my data, that users consent around what is happening to them, that the user benefit is really clear, and that it's also made transparent to the user. And I think overall, as a society, that's a huge beneficial push, because it basically turns data into like a fundamental right. And even though it may slow down development a little bit here and there, like still overall as a society where AVs are hopefully an exciting part, but not the only part of moving us forward, it's part of the rules of the game.
Yeah, and I feel like it's not necessarily slowing down the development, it's going to slow down the deployment. So, I mean, working at here, obviously, we've been working in data for a long time. Privacy is at the heart of everything we do. We have neutral servers, we have informed consent tools that we offer our customers. We have libraries of anonymization tools that we offer our customers. But as far as, you know, providing data and getting back data during the R&D phases of self-driving cars, I haven't really found a hurdle there. I think there's the age-old question of, you know, who owns the data, you know, who owns the liability in the car. I think there's a lot of people out there who think their data is very, very valuable. So trying to make agreements about purchasing their data gets a little tricky. But I don't feel like it's impeding the actual development. It's definitely going to slow down the actual deployment of the vehicles itself, I would say. But I think, you know, there's tons of anonymization tools that are out there to help us. And we've, you know, done all sorts of studies that say, you know, you can't just anonymize data and take the person's name on it. People are creatures of habit. They're going to drive the same road, or they're going to get up every day and go from their house to Starbucks, and somebody's going to figure out that charge at Starbucks is the same person, right? So there has to be some pretty intricate, you know, integral tools to be able to do that. But again, I haven't seen it slow down the development, more slow down the deployment, and then how we actually give informed consent to the end user of what their data is being used for.
There's one, you know, one place, sorry, my dog is going to say,
Okay, awesome.
This is Ellie. So there, you know, there actually is one area where we have seen with customers data privacy potentially slowing down some of their machine learning model development, because you start to have this issue where if you go out into the real world and collect data that contains personally identifiable information, let's say somebody's face, and you then go train a model on that data, and you want to deploy that model out into the real world, there may be consequences with either current or future privacy laws that actually require the company to be able to go back and obfuscate that personally identifiable information. And so some companies we found can't collect data in certain ways that contain easily identifiable faces, because they don't want to have to go back and you know, remove that data or obfuscate it in the future. And many of the European privacy laws already mandate that they do that. So some of the customers we're working with actually turn to synthetic data as a way to be guaranteed that there's no personally identifiable information, because we don't use real people in our simulations. We just use people that look like real people, and they're, you know, they're different than the actual, you know, real copy of somebody. So, you know, we found a lot of cases with customers that want to get the cameras close to people, and that having synthetic data that comes with it this guarantee that it's not a real person that you're going to have to go back and obfuscate later is a big advantage. Another area where we've seen it potentially influence development is where you actually have to go blur a face, and actually recognizing a pedestrian with a blurred out face is a lot harder than recognizing a pedestrian with an actual face on it, and figuring out where that pedestrian is looking. There are companies like Perceptive Automata that does prediction and gaze tracking of pedestrians that are on the street to figure out where they're looking and what they're doing. But if you have to go back through your data set and blur out all the faces, all of a sudden it becomes really hard to figure out where a person is looking, which in turn then makes it really hard to predict where that person is going to walk next. And if you're somebody that's about to cross the street, it's very likely that you'll look at that street before you cross, and that can often be a clue that the pedestrian is about to do something. So we have seen some impacts on development, but I do generally agree that these actually manifest when you want to deploy, right? So if you want to go out into the world and collect a bunch of data and use that only for internal purposes and never deploy a model, this might not end up really affecting you. But at that moment that you want to deploy, you have to be really cognizant of these privacy regulations. And that means that you would have had to really been taking this into account from the beginning. And so a lot of companies we work with today are taking data privacy into account from the ground up as they're out collecting data. And it's another way that synthetic data can often help.
So with data being so critical to the development of AVs, do you think, and this was a question that came in around data sets and how closely guarded data sets happen to be for a lot of companies. Is this something that the government should be taking a step in terms of releasing large data sets to the public that want to accelerate development, to accelerate safety? I mean, we kind of saw this a little bit around, you know, the vehicle OEMs, right, where they had safety measures that they kept in their car for a minute and then they released out to the broader world once they realized why are we keeping safety measures, you know, ourselves. So is there a parallel there that we can apply here? I mean, are companies going to be forced to do the right thing, or is this just going to continue to be a walled garden kind of approach?
I'll drop one thing in quick and then maybe let the others respond. You know, one thing that we've found with data sets working with multiple customers is that they have a lot of specific requirements, especially around the sensors, that data set be collected with the sensors that they're going to go use. So for example, and again, I'm going to very much talk from the, you know, the kind of vision perspective. There's probably a lot of data out there, such as scenario definitions and safety standards that totally should be set by the government. But in terms of vision data, we're finding that each company needs to go collect that on their own. And even those, you know, big Waymo open data set, Berkeley Drive data set, Autonomy data set, they're interesting for research applications, but for both legal and technical reasons, they're really not usable by other commercial customers because they'd need to capture that data using their sensor configuration. So it's a bit of a hard problem, at least on the vision side of things, to release, you know, broad data sets that would be really meaningfully helpful to a lot of these companies. Where I do think that changes though is potentially on like scenario definition, safety standards, standards around deployment, standards around privacy and best practices and traceability though. And I'd be curious to hear, especially with mapping and some of the stuff that Sheila and Christian have been doing, if you've run into this more.
I think for, so in our case, we've been in discussions essentially primarily with OEMs relating to the question of how much they can actually share or they feel comfortable sharing in that sense, which frankly speaking isn't a lot because they are, I would say, are rather protective and I guess as Tim from NVIDIA here posted in his question, they see it a little bit as their crown jewels that they do have to protect. I think a huge opportunity from kind of a regulator side is on the side of certification or security checks of AVs before deploying, or maybe even regular security checks which are being conducted. And there I see that as an opportunity actually between countries, between nations to kind of, or the respective organizations there to share data sets to ensure that from a regulator standpoint to release specific types of vehicles onto the road and give them a thumbs up, that there is an exchange and that, let's say, the progress that Singapore and China and the US have done in terms of deploying vehicles can also be shared with other countries who, like Germany, for instance, because despite the fact that a lot of great car manufacturers build their vehicles here, the rate of deployment, unfortunately, is still far below some of the world leaders in that sense.
Yeah, the only thing I was going to add, I see the same thing Christian does, right? Every OEM kind of has different, feelings about how they want to share their data. And some of them want to give us back their data only if it's going to improve the product that their cars are receiving. So it's a direct benefit to their actual customers of the car. I think industry-wide, there's a belief that we should be sharing data that's safety relevant to help the whole entire car fleet. And then the thing that HERE has done to try to help in this neutrality of this is create what we call neutral server, where it allows an independent person for all the OEMs to come and be able to share and essentially barter their data for other uses for third-party applications in an anonymous way. So we're kind of the neutral player for all of the data to be shared right now. And we announced earlier this year that Daimler is actually the first person who's sharing their data on our neutral server in that way.
And to that point, I think the concept of neutral servers in that sense is actually really critical in that, because individual players just sharing their data, there are great examples of that, but it doesn't go to the heart of AV, I would say. Let's say BMW has open sourced pothole data and pothole detections in that sense. And there are examples of that where this, from a society point of view, has a huge benefit. But at the same time, let's say any one of the OEMs opening a core data set for AV will always pose questions around the risk of reverse engineering and potentially exposing some parts of their system to a risk that otherwise is currently mitigated, essentially. I think there the neutral server approach is a good example of creating a bit of a playing field where, like, maybe also through the aggregation across OEMs, you limit the risk of corrupting your own security.
Mm-hmm.
Something I wanted to add into that, just to jump in, because it was inspired by a couple of things that Sheila and Christian said, and especially along the lines of Tim's question about, these companies consider data their crown jewel. How do we democratize access to this data? And tying into your question, Brent, about how government might be able to set standards and share that data out with people. This is actually something that synthetic data can help a lot with, because we can take a definition of a scenario, we can take a collection of scenarios, a collection of locations, and generate synthetic versions of that data, and then regenerate that data with anybody's sensor configuration, right? So if the government sets a scenario standard, and they may go out and collect real data given one sensor configuration for that set of scenarios, we can then regenerate that set of data synthetically with different camera and LiDAR configurations so that all customers could then go use that as part of their stack. And in the end, what this really means is that we're trying to make data so fast and so easy to generate that anybody can generate the data that they need, rather than having to be a multi-billion-dollar company that can buy 2,000 vehicles and pay safety drivers to drive them around the world to collect data. We'd rather have people use an API and generate that data much more quickly, much more cost effectively as they need it. So we do see this movement towards synthetic data as a bit of a democratization effort, because it really massively lowers the bar to getting data. You can generate data without leaving your desk. You don't actually have to put a car on the road to get that data.
So I just want to say that when I have dropped the term synthetic data in conversations, it's always a showstopper. People are like, wow, what? And I can see already there are a couple of questions around what exactly are we talking about with this synthetic data thing? Like, how do you generate that? Is that really realistic to train a model on it? So I don't want to turn this into a company showcase of parallel domains technology, but if you can just take a minute to high level what we're really talking about in terms of how synthetic data is different. I know you touched on it a little bit, but maybe people are late to the show, versus what Sheila's doing with real world. This is the actual data coming off the street. Like, how is synthetic data different, and what would someone purchasing that expect in terms of the differences of training a model on it versus hard data like yours?
Yeah, there are, I'm glad to dig into this. There are a couple of different kinds of synthetic data. So I think first it's worth establishing generally what I mean when I say synthetic data, because I'm talking about the type of data that we at Parallel Domain generate. But there's kind of a broad spectrum. So there are techniques called data augmentation, where you might go out into the real world and collect lots of real world data, find interesting things from that data and composite them on top of each other and generate new variations. We generally don't focus on that as much, but that is an approach that is technically synthetic data, because you've synthesized something new, but it's actually sourced from real data. There are other techniques that use deep neural networks, and NVIDIA has done a lot of work here to completely transform one type of data to another, maybe transform a driving sequence from summer to winter or from day to night. While we do employ some of these deep learning techniques at Parallel Domain, we also don't go quite that far in terms of just completely neural network-based synthesis. We fall somewhere in the middle, which is what we do is we take real world data inputs like map data, GIS data, elevation, satellite imagery, and we generate a virtual environment that is an approximation of the environment that would have existed for that location. And within that virtual environment, we can run lots of simulations and simulate sensors like camera, LiDAR, radar, GPS, motion units within that environment and generate what we would consider kind of from the ground up synthetic data. Because everything in that data set is rendered by a computer graphics system. These are all very highly calibrated systems. We push way beyond the technology that's done in games and film to make sure that all the physical units are accurate, to make sure that our sensors are actually simulating real camera sensors, real LiDAR sensors. But this data is really from the ground up synthetic. So if you want to move a building, if you want to change the time of day, if you want to generate the exact same sequence of a bicyclist crossing the street and do that at 10-minute increments as the sun moves across the sky, these are all things that you can do with synthetic data. Now, the critical thing is that it's realistic enough to train a model, right? If what we're talking about is training deep neural networks, there's development, training, testing, verification, all sorts of paths here. But if we're going to focus on one of the most discussed topics, which is, can I really train a neural network on synthetic data? The answer is absolutely yes. And we do it all the time. And we do it with our customers, and we beat their state of the art when we mix our data in with theirs, right? So they go out and they collect real world data. We generate synthetic data. Often those two data sets are similar, but might complement each other. For example, we can generate more pedestrian crossings, more yellow lights, more rare cases that their data set might be deficient in. We can then mix those two types of data sets together, and when they train a model that is then validated and tested on real world data, it actually performs better than it did with the real data alone. We also have customers that train models from scratch on synthetic data and get really usable performance, not as good as when you mix real and synthetic together. But this is very achievable today as long as your data is high enough quality. All synthetic data is not created equal. Data that you get out of Carla or that you get from some of the open source like Virtual Kitty data sets is not going to train a model to the same quality as some of the stuff that more of the professional groups produce. But as long as you can hit that quality bar, hit that level of variety that's required, you really can make a very positive difference in training models that go out into the real world and do real things.
So while we're on the topic of data quality, shall we say, and Sheila, you had mentioned this a little bit around, here kind of waiting very patiently for the advancement of ADAS features and things to be able to gather more real world data, et cetera. What challenges, and this is for you too, Christian, what challenges do you have in terms of being able to capture the right information that your customers need versus the irrelevant stuff that nobody, that is not super helpful? How are you going about doing that?
Yeah, so we work with our customers. We've actually developed a spec called Maplets that actually helps customers do this. So if they have their own perception stacks, we've essentially given them a spec to say, please don't send us all of your data. That doesn't help us. We need, exactly these observations and this cadence this many times a day so that we can really package up that data to be meaningful for us to be able to update our map real time. And then it helps obviously with, their bandwidth that they require and keeping their costs down. So we work really closely with them on that. The other thing that, since we do have our own fleet of industrial capture vehicles that we've had forever for our SD map, we have, long time experience in campaign management of, hey, when I know my data is old in this area, how do I go send out a car? So we're working with our customers to help them develop their campaign management to be able to say, X OEM, I am missing these streets in Munich, for instance. So I don't want the rest of Germany, I just need Munich right now. So those two things together, we just work really collaboratively with our customers. And then there are data sets out there that already have been packaged up pretty nicely that we can actually, just ingest as is. But obviously for my map, all data is not created equal, like Kevin said, right? So I need data that will actually help me hit the accuracy targets that are required. And sometimes that's in centimeters of accuracy. So by combining our Here True fleet that is super high sensored, like L5 vehicles would be surrounded by LiDAR, with the vehicle sensor data that's coming from these ADAS systems that maybe can detect the change and then I can verify it a different way, it allows us to be able to update the map and maintain the accuracy that's required in real time.
Yep. One of the huge data fusion problems, like in general, and this is not specific to AVs, this exists in other industries as well, as essentially like in those setups where like ideally to build the best system, you're depending on data from different stakeholders in that sense, and different sources in that system. So the OEM, the tier 1 supplier, tier 2 supplier, the infrastructure provider, and so forth, who are all contributing data, which let's say could be pulled together on a map or on a different layer, essentially. That all requires synchronization around data models, for instance. And in that context, the push around common data standards is actually a critical one. Unfortunately, there isn't one common data standard. There's more like 10 different or 10 common data standards in that sense. So that creates a bit of complexity again then. But overall, this push is critical because it basically helps in a certain way reduce waste in this whole process of moving together data. And today this requires a lot of transformation, normalization across different stakeholders, even within OEMs, where oftentimes data models are not unified across different vehicle models. And there's a lot of complexity behind that to really move the data from, let's say, the 900, 1,000 different data points that an OEM collects on a vehicle, kind of over its different data points over its lifetime, like from a vehicle. There's a lot of standardization to be done and to be agreed on, or in our case, that's one of the topics actually that our customers are looking at, tool set or tooling that easily facilitates kind of this normalization process for them.
Right, and then the different sensors on the vehicle, depending on what, if it's an L3 vehicle or an L2, L2 plus, right? If they're fusing the data in the car, it's going to be better data on a car that might have a front lighter on it, right? So that's going to help me with certain features in my map. And I will say that it's in both of our benefit, right? Like I don't want to take data I don't need because that costs me money for processing and AWS costs, and they don't want to spend the money to harvest unnecessary data off the car. So it's really been a very collaborative approach with our customers on that. And then setting that spec, we've gotten quite a few people to adapt to our spec. And that's even beyond OEMs, dash cam providers. I mean, we play with all sorts of people who collect data in different fashions in the car.
Yeah, big plus one to everything that's being said here. I think taking the very repetitive data that you get from driving on street after street after street and mining that and filtering that for the data that really matters is a very difficult problem. And that's something we work with a lot with our customers on, is how can we generate the data that complements that repetition, right? Very often a customer drives around and sees 96% red and green traffic lights, but yellow lights, even though you see them all the time as a human, they're actually very rare relative to the amount of time you're driving around. Only about 3% of the time do you see those yellow lights. So just being able to flip that distribution and generate data that is not as repetitive, so you can kind of throw out the stuff that's a repeat, is a big challenge, something we work with customers a lot on.
Cool. So I want to spend the last couple minutes here before we dive into questions on the frontier. What does the frontier of data look like? Like what are the sources of data, the types of data that you're just now hearing about that may be just coming online, or maybe it's, we're looking at it coming online in the next few years or something? What is exciting out there that the people here would not have heard about yet?
Isn't it obvious? It's synthetic. We've answered this question, right, Kevin? No, I totally honestly, after this call, we're totally all getting together, right? I think that we're seeing some incredible stuff with like high precision mosaic satellite imagery and what you can do with that, and how accurate and feature extractions you can do with that kind of stuff. Again, our little secret sauce is that we conflate multiple data sources. I think there's tons of great government sources out there of data for construction feeds, incident feeds, speed limit information, right? That gives more live data to augment some of the stuff that we're finding from drive data. That's my answer.
Yeah, and even within synthetic, and thank you, Sheila, I totally agree. The future of data is synthetic, 100%. Even within synthetic data, we're able to generate data types that you cannot get in the real world. Just to use some autonomous driving use cases, for example, we have the 3D model of the entire scene and all the cars in that scene. Well, it turns out when you have that as a ground truth, you can actually estimate the position, orientation, and pose of every car and human in that scene much more accurately than you can when there's a human drawing a box on things to label, right? And so having that 3D information, we can produce depth, we can produce optical flow, we can produce pose and state information, trajectory information. We know before something crosses the street that it was about to cross the street, and all of that kind of intent information can be used to train new models. Toyota actually published a research paper on top of our data showing how they can more accurately estimate the pose of a car because they have full three-dimensional data from us, which they just can't label with human labelers, right? So there are actually groups now that can train neural networks for new tasks on synthetic data that are very difficult, if not impossible, to get those types of labels on real data. And so we'll probably be publishing some things in the near future as well about the data types that we export that have enabled customers to actually train new types of models that can make even better decisions for these autonomous systems.
I think for us, one of the key areas that we've been excited about for a while, and it's a space that is heating up now, is essentially the data or partner orchestration part outside of the vehicle, which becomes a bigger and bigger topic, a bigger challenge to solve once you actually have more vehicles running around, and actually the whole AV space moving from an engineering problem on the vehicle to much more of a logistical operations problem of moving people at scale and kind of working within a city ecosystem, for instance, because at that moment, those vehicles are much more integrated into infrastructure, everything from charging to toll bridges to a parking infrastructure if needed of some sort, and other types of communications, also maybe even with certain points of interest that users want to interact with, creating links to other modes of transport, because maybe an AV is just a means of getting to a train and you actually want to create a convenient experience around that. All of that means that you require connectivity not only from the vehicle, but also from the other side. And there's a lot of that happening as we speak. It started a few years ago with kind of the first, let's say, parking locations, parking infrastructure becoming connected. A lot of the charging infrastructure is still not well connected today. We're seeing a lot of shift there. And overall, there's more and more push into that direction because it's a stepping stone into creating an actually functioning ecosystem of AV vehicles over the next 10 years.
Cool. All right, so let's dive into a couple of the questions. I just want to tout my own horn that we are almost exactly on time. This almost never happens. Just full disclosure. All right, so Stefano has a question. What do you think about the NHTSA AV test initiative? Can be the release of the data set an extension of that?
Yeah, the short answer to the second part of your question is absolutely. So there are a fairly large variety of different standardized test initiatives. The NHTSA standard is one of them. There are Euro NCAP, there are a handful of European, both for-profit and governmental agencies that publish safety test standards. One of the things that we see in like verification and validation a lot is a customer wanting to have data sequences that match these test scenarios. So absolutely, we could generate varieties of synthetic sequences that match those test scenarios and allow you to actually train, test, and verify on those sequences before you actually have to go out to the real world to verify them. So absolutely. Another part of that, generally speaking, is that we think it is very valuable to have external data sources, right? So very often you see a machine learning team collecting and curating their own training sets and their own verification sets and certifying themselves to be safe to put that car on the road. I think we and many other folks in the industry, especially those that are building independent companies, believe that that's a bit dangerous, and that a lot of these companies really should be tapping into both external data sources as well as external verification sources to help them test their models in an objective way, which an internal group would really have a hard time doing.
Mm-hmm. Sheila, Christian, any thoughts on the on that?
No, I didn't really have anything to add. I totally agree with you on your last point, and that's actually something we do, right? We obviously collect our own data, and we can go back and verify, you know, with humans that our map is correct based on our own data we've collected. But we actually, on top of that, go acquire other data sources as another double check to validating and verifying our own data, because, you know, it's kind of like, you know, giving the answers to the test before you take it otherwise, right?
Makes sense. Christian, any thoughts?
Nothing to add.
Nothing. Okay. All right. So Kevin, there are a couple of very specific questions here. Dimitri is wanting to know, how realistic is it to train a model, which I think you already addressed that. But I think he's saying with only synthetic data, and you mentioned that kind of the best results you've seen is a mixture of real world data with synthetic data together. And he's asking, how do you ensure that the model is not overfitted to the computer image?
Yeah, it's a good question, and it's one that's a very active area of research in machine learning. So to answer maybe that in two parts. So it is very realistic to train a model on synthetic data only. Again, we have active customers that are training on synthetic data only, and then actually going to validate and verify those models on real world data for real world operation. And so these models do learn very valuable things from synthetic data, and they're able to transfer that to the real world. Again, as long as your synthetic data is realistic enough. And this is something, you know, a lot of folks on this call will be familiar with the domain gap, where, you know, when you generate synthetic data, that's in a synthetic domain. It might be familiar with the name parallel domain. You might start realizing where that name comes from. But we generate data in a synthetic domain. Of course, there's going to be some difference in the characteristics and in the distributions of the data that we generate to the data you'd collect in the real world. Now, the main question is that difference actually better or worse? And in many cases, we find that we can generate varieties and a level of accuracy in our data that you can't get in the real world. So yes, the domain is different, but in some cases, it can actually train more robust models. And there are a handful of techniques that we use, such as fine tuning, domain adaptation, and style transfer, that actually allow us to take the target real world domain into account when we're training a model on synthetic data, and have the synthetic data drive the large feature learning, right? Learn the large features from synthetic, and then use real world data to just fine tune a little bit at the end. Use 1/10 of the real world data you would have used, have synthetic data drive the majority of that training, and then you end up with models that can typically outperform what you would have been able to do with that original batch of real data.
Cool. And I'm assuming that the data sets are applicable to both cars and trucks, right? I mean,
That's
anything that really moves.
Cars, trucks, delivery robots, drones, satellites, doorbells, laptops, cell phones. You know, if you want to perceive an environment and something happening in that environment, you can generate synthetic data of that environment. You'll actually find, you know, we focus very much on exterior environments. There are other synthetic data companies that generate data more focused on interior environments or human faces, or you know, different, and there's even some companies that generate synthetic data of animals we've seen, right? And so there's a, you know, a very broad application. The computer vision world is huge. We tend to focus on autonomous systems, which is a system that needs to navigate an environment. So we generally fit into all of those use cases.
So I think one area where just to kind of give a bit of a different twist on the question of cars and trucks, one area where it obviously differs is on some of the informing data streams around it, which, you know, can be represented on a map like point of interest information. In that sense, that is obviously relevant for the operations of those vehicles, where it differs in terms of some of the roads that you're allowed to take in a city, some of the points of interest that you're going for, where you have two pretty distinct categories, or actually even more than that, because you have special categories like delivery vans, which may have special rights of or special zones in the cities that they can leverage. And that's where it becomes a much more complex differentiation in that sense of between trucks, cars, vans, robots, and whatever is zooming around.
So is Zappix and Here also working across drones, scooters? Like, does it matter? Airborne, terrestrial, autonomous? What are there any limitations to what you're looking at, or are you also playing the entire field?
And we're playing the entire field, right? So, and we already have things like you were talking about. So we already mapped sidewalks for the bots that might want to drive down it. We already have very specific trucking attributes, like areas where you can't do that braking noise, like the trucks have to identify it. So we can actually kind of customize the maps we provide based on their use case they're trying to do. And that also helps them minimize the data size being sent onto the vehicle. They don't need a map of, if they're only ever going to drive on highways, then we can just give them a map of the highways and give them all the truck stops if that's what they're interested in, right? Drones, I'm not so much sure there. That might be some frontier work for us, but we're pretty terrestrial right now. But I would say, yes, we look at everything, absolutely.
So for us, it's mainly the focus around data that's streaming of cars and trucks, essentially, and then being connected both with the ecosystem and those partners, which are then also adding value-added services to that.
Yeah, and so we take in all data sources, so we're definitely not limited just to cars and trucks, but the cars and truck data to me is what gives me the freshness of my map, right? So I can go build a map once a year based on probe data if I want to, but if I want a super fresh map to know they just changed the paint markings on a road one day or stuck up some construction zones, that vehicle sensor data is really key to the freshness.
Totally. So the remaining 3 questions are all about synthetic data. They're wanting to know, how do you know that synthetic data reflects reality? Do you release any of your synthetic labeled data sets into the public domain? And then, Tim's got a question about how do you correlate the driving algorithms on the synthetic data to, real world data?
Yeah, we can run through those quickly though. So do we release data? Yes, we do. There are some research papers out there that have used our data and have released that data publicly. Email us, info@Parallel Domain, Kevin@Parallel Domain. We'll point you to it and get you set up. We also generate sample data sets very quickly for customer prospects if they want to see something specific. The other 2 questions, actually, we can take at once. I think the question is really, how do you make sure an algorithm you've trained on synthetic data is going to perform well on real data? How do we know that data is realistic? How do we know that it's teaching the model to do the right thing? Just to zoom in on the training use case, if we're training a model on synthetic data, we almost always verify or validate that model on real data, right? And so when we're doing benchmarking with a customer, and we've done this with a bunch of our current customers today, is they'll provide a kind of double-blind set of validation data that we will, we'll inject our synthetic data, they'll train a new model, they'll go validate on that real data and make sure it got better. At the end of the day with machine learning, what you want to ensure is that your model got better on real data. And that's the general metric that we're using to gauge perception systems in particular, to gauge their performance. So as long as we're verifying on that real data in the training use case, we have a pretty good indicator of how that thing's actually performing in reality. The flip side of that is, how do we validate, verify, whatever kind of word you want to use, on synthetic data? What we typically do here is we establish correlation tests, right? So we'll generate analogous sequences that have been, you capture a handful of calibration tests in the real world. We'll generate those calibration tests and synthetic data. We'll make sure we get one-to-one performance on those. We'll make sure that those two tests cover a broad enough range to give us confidence that we've kind of covered the space and that the data is realistic enough to evoke similar performance on our synthetic data versus the real data. And then you can start to scale up validating on that synthetic data. But it's always part of a regimen, and real data is always at least part of a part of the mix. But we typically find ourselves being able to displace the largest volume of real data with synthetic so that people can be a lot more efficient about what they're doing.
And is it US only or Canada too?
So we do all sorts of countries, although this may have been aimed at the...
this could have also been to Sheila.
Yeah, we do all sorts of countries all around the world. You want Japan, Germany, we do farmland, we do cities, we do a lot of different stuff.
Do you model the different driving behaviors though? I mean,
yeah.
Erratic, because driving in India is very, very different from driving in Connecticut.
Yeah, exactly. And to be clear, there are regions that we don't have online. Like we don't do India yet, right? But we have Germany, we have Japan, we have the US and a couple other locations. And we do model different driving behaviors, but there are definitely behaviors that our platform doesn't capture, right? And a big challenge that we have in front of us is building a platform that's robust enough to generate all of those different behaviors so that we get good coverage.
What about here, Sheila? Are you guys, I mean, here is a European collective, right? So, but how global is here's data?
It's really global, right? We cover all the continents. For SD, we pretty much cover all the continents. There's certain countries where you can't collect data. You have to be local to do that. So we have partnerships in China and Korea and Japan for that operation. For the HD map specifically, we're currently building out coverage in all of North America. So absolutely in Canada and Western Europe, those are our first target markets based on my first launch customers. And then we have lots of demand for Singapore and Israel, all the other hotbeds where AVs are being developed and tested. So absolute plan will be all road types globally.
Christian, what about you guys? Are you all working globally or are you focusing in a particular market?
For us, it's mainly Germany and the US actually right now in terms of and Sweden. So yeah. We're a bit picky about the countries there. No, obviously not about the countries, but there's the OEM space is limited in that sense, and they've only chosen a few.
Okay. Well, we've actually gotten through all the questions, and this is the first time we've successfully managed to do that. I think it's because our panel is so awesome. I want to thank Kevin, Sheila, and Christian for participating in this event. This was, I thought it was great. You had me spellbound the entire time. And I want to thank Angela for her work in putting this together and getting us online and making sure that everything is recorded. Once again, this has been recorded and it will be shared out. So we'll make sure that everybody gets that. And if anybody has questions about contacting the panelists, you can either just reach out directly, or if you didn't catch their contact details, you can reach out to me through the Meetup page and I will be happy to share that with you. So thank you so much for everyone who attended. This has been a great event, and I hope everyone here has a wonderful weekend. Try to get outside, even if you're in California. And Christian, please go to bed, man. It's got to be like 2 in the morning.